Machine shop work. Bench work is an important part of the work of every machinist. Cutting threads with taps and dies is work often performed by hand. Machinery is made up of parts for convenient machining and assembling. These parts are fastened together with screws, studs, and bolts provided with threads. Coarse threads like this on work of big diameter are always cut on machines. Threads like this may be cut by hand. Whenever parts are held together by threads, one part must have a thread on the outside called an external thread. This must screw into the other part, which has a thread on the inside called an internal thread. External threads, when cut by hand, are cut with a die. Internal threads, when cut by hand, are cut with a tap. Oftentimes, blind holes, which do not go through a piece, are cut at a bench. This piece, for example, is the body of a fuel pump. An internal threading or tapping job of this kind starts with the unfinished piece and a study of the blueprint, which shows that 2 tapped holes are required, each 5/16 in diameter, 1/2 inch deep, and with a 24 pitch thread. The blueprint also shows the location of the holes. These must be properly located. And center punched to help locate the drill. The next step in tapping is drilling the hole. Be certain that the drill is the right size. The sizes of tap drills are calculated in terms of the outside or major diameter of a thread and the inside minor or root diameter of the thread. This blueprint gives the drill size as 17/64. Some blueprints give only the size and number of threads used on the tap. In this case, you may refer to tables to find the drill size. It should be understood that the size of the drill given provides for a standard 75% fullness of thread. The strength of a threaded connection is determined by the fullness of the threads. In accepted shop practice, a 75% full thread is used for a strong connection. In a 75% thread, the external thread overlaps the internal thread 75% of the full thread depth. If the hole is drilled too large, the tap will cut only a shallow thread, which may give us only a 50% thread, making a weak connection. On the other hand, using a hole small enough to give us 100% thread adds very little to the strength of the thread and results in the breakage of many taps. When tapping holes in soft metals, a tap drill one size larger than the size given is selected. These metals draw and flow, making the hole smaller. The 17/64 drill called for by the blueprint is selected. The hole is drilled, and all chips carefully removed from the hole. The blueprint indicates that the outside diameter of the bolt is 5/16 with 24 threads per inch. This gives the size of tap 5/16, 24. Make sure that you have the correct size. Taps always come in sets of 3, known as taper tap, plug tap, bottoming tap. The taper tap has a long taper from the tip to a full-size thread. This tip helps to guide the tap straight in the hole. This is the first tap used in hand threading a hole. On the plug tap, the threads start at the tip with a sharp taper to full size. This tap is used as the second tap to follow and deepen the threads started by the taper tap. The bottoming or finishing tap is necessary to complete the threads to the bottom of this blind hole. This third tap is not always used. Taps must be sharp to cut a full thread easily and without breaking. An adjustable double-end wrench is used to hold and turn the tap. The square head of the tap must match the square formed by the wrench jaws. The taper tap is inserted straight in the hole. After a thread catches, one full turn is made. The worker now stops and checks to make certain that the tap is square to the work. A machinist scale may be used to check the squareness. It must check at 2 positions 90 degrees apart. The tap is not square with this work. It must be squared. The worker now gives the tap 2 full turns. He now checks the straightness of his tap again. An experienced machinist can do this in this manner, sighting from 2 points 90 degrees apart. Notice the steady, even pressure of the hands on the tap wrench. This pressure needs only turn the wrench. The thread pulls the tap into the hole. Lubricant is added from time to time as the work progresses. With experience, the bench worker learns to feel the action of his tap. When the turning becomes harder, instead of forcing the tap, he backs it up about half a turn, which breaks the chip and permits the lubricant to reach the cutting edge of the tap. Small taps such as this are easily broken. Bench workers exercise the greatest care to avoid such breakage, since a broken tap may ruin the work. And at best, the removal of a broken tap is a tedious task. This is one way of removing a broken tap, or a tap extractor may be used. Tapped holes are seldom very deep, and since the taper tap has a long, unthreaded tip, great care should be used not to force it against the bottom of the hole. Before the taper tap reaches the bottom, the bench worker backs it out and removes all chips from the hole. He is now ready to use the second or plug tap. This is inserted and turned in the same careful manner as the taper tap. The plug tap continues the thread started by the taper tap. Again, be careful when approaching the bottom of the hole. The third tap used in the tapping of blind holes is the bottoming tap, which completes the thread to the bottom of the hole. This job is completed. Depth of the thread should be 1.5 times the diameter of the bolt to provide a good, strong connection. This is a through hole and larger hole, but the same care and procedures are used in threading it. The one exception is that in through holes, the taper tap may be the only one used. The plug and bottoming taps may not be required. Another type of wrench for holding taps is the T-handled wrench, often used for the smaller taps and to extend the length of the tap shank. The one-end wrench is used in corners or where a full turn is impossible. Once the hole is tapped, the next job is to cut the threads on the part that screws into the hole. Again, the blueprint provides the information to guide our work. In this case, a stud is to be threaded to fit this hole. It is 5/16 diameter with 24 threads to the inch, same size as the tap. A stud, such as used here, is a straight piece of round stock threaded on both ends. External threads on small pieces like this are often cut by hand at a bench with the use of dies. It is good practice to chamfer the end of the stock. This protects the finished thread and helps start the die. Our piece is to be 5/16, so we select a 5/16 24 thread adjustable die. There are other types of dies, some adjustable and some solid. The adjustable die consists of the wrench, the die holder, and the collar. In assembling the die, make absolutely certain that both parts of the die have their tapered portions of the thread toward the guide collar. Each part of the die assembly must be wiped clean to ensure accuracy of cut. Here in animation, we see the action of a die in cutting a thread. The collar acts as a guide to ensure the squareness of the die to the work. The tapered portion, or the throat, starts a shallow cut, gradually increasing in depth as the work progresses. The first step in cutting an external thread is to adjust the jaws of the die for a trial cut. The approximate size can be secured by trying a threaded bolt of the same size and thread, being careful not to set the jaws too close together, since a cut too deep will ruin the work. Since the guide collar keeps the work straight, we need not check the straightness. As soon as a trial cut is made, the die is backed off the stud. The stud with a trial cut is checked in the tapped hole in which it will be used. The thread is too shallow and does not catch, so the jaws of the die are set a trifle closer to cut a deeper thread. Notice the size of the die cut thread is adjusted to the tap thread, which sets the standard. Therefore, the tap thread in which the stud is to be used is cut first. The jaws are now set to the correct size as the threads fit the hole tightly. For convenience in holding the stock, we have threaded one end before cutting our stud to length. A stud nut may be used to hold the stock in the vise. The piece must be held firmly without injury to the threaded end, while the second end is being threaded. A stud nut that fits easily and firmly is used. The die jaws are now tightened to cut a slightly deeper thread for the nut size than used for the body thread of the stud. This thread is checked against the nut, which will be used. The nut goes on freely, and the threading is completed. In order to screw the stud into the fuel pump body, the bench worker uses a stud nut to protect the threads. Remember, the threads on this end were cut oversized to fit tightly into the threads of the tapped hole. When a blind hole and stud are properly threaded, the stud will screw into the hole with a close working fit. When both threads are the correct length, the stud will not touch the bottom of the hole, and only a portion of unfinished thread is visible above the surface of the work. This holds true for small hand-threaded studs only. The job is complete. Let's review the operations. The bench worker who takes pride in his work follows the blueprint carefully, selects the correct drill, knows his taps and dies, uses both correctly, and checks his work. Each step of the job is carefully done, and here is a complete fuel pump held together with threads cut by a bench worker skilled in the use of taps and dies.